Welcome to the tutorial for Lab 4. So, in this tutorial, I'm going to teach you how to use signals to communicate between robots and to coordinate an environment so we can do cooperation between robots. So, the first thing that we need to know is it's how to use signals. I'm going to open thing that I have over here with all the important functions that we need. Okay, so these are the functions that I told you in class, and they're very simple. This sim set interrupt signal sets a signal, and this one reads that same signal. So this set interrupt signal needs two values. The first one would be the signal name, and then the value that it will have. When I get the interrupt signal, I only have to indicate the signal name, and this value over here that I'm receiving will be the value that I have set when I set the interrupt signal. This result variable that I have over here I only have to pay attention when it gives me -1. If it gives me a -1, it means that this was not successfully completed. So if you're having any errors or problems, abnormal behavior, you can check that this is not -1. So there are two new functions that I want you to know. The first one would be sim clear interrupt signal. So for most of the time, we actually don't need this value over here to be reading it to identify what type of signal it is, because we only want a true or false value, right? For most of the cases, what I want to know is to activate or deactivate a signal. And for that, what I can do is simply set this signal, and I want it for activating it, and when I want to deactivate it, I just clear the signal. It's a lot easier for a lot of things. So if you just want a non-enough type of behavior with the signals, you can set it first and then just clear it when you don't want it to be active anymore. The second function that I wanted to teach you is the sim wait for signal. So this, what it'll do is that if you have a process, it'll stop it and it'll wait for the signal to be activated. This will not execute any other code while this signal doesn't appear. Okay, so this sim wait for signal only works for threaded scripts. So this is probably the first time we address this, but in VREP you have two types of scripts. Non-threaded scripts, and you can recognize them because they're kind of grayed out in here, and the threaded scripts because they're kind of bluish. So what's the difference? So a threaded script will execute only once. Okay, so if I hit play, the code will execute only once. And with robots, you always use a threaded script because you don't want the code to execute with each step of the simulation. On contrary, when we have a non-threaded script, what will happen is that this will execute with every simulation step. So every time you see the clock going forward, it'll mean that this executed once. So this will execute 1,000,000 times in a very short period of time. What we want to do first is I'm going to give you a very small example of how to use signals to communicate between robots. Okay, so the first thing that I'm going to do is that in this robot in here, I put a wait, so it would pick up the first piece, so you guys could have it over there. I'm going to delete it. And if I hit play, what you'll see is that both robots are moving simultaneously. Okay, so the first thing that I'm going to show you is I'm going to call this robot 1 and this one robot 2, or yes, I'm going to call this one robot 1 and this one robot 2. So the first thing that I want to do is I want to make robot 2 wait for robot 1 to be finished with one cycle of movements. It is kind of repeating its movements. So I want robot 2 to wait for robot 1 to be finished with one cycle of movement before it moves. Okay, so what we want to do is from this robot, we want to send a signal to this robot saying that this robot is ready for its first cycle of moves. And in this robot, we want to wait for this signal. So let's go to this robot first. As you know, with this script, this is not how your regular previous scripts were. So in the past, what you guys had is at the end of the code, you would put all of your commands in here and they would execute. This one is just a little bit different. So in here, we're executing this thread function, and this thread function is the one that will actually have our commands. So if I go to this thread function over here, this is the function that I'm interested in, that you guys will be changing. So what we want to do is in here before, okay, so what we want to do, I'm going to take this extra commented elements and delete them so it's a little bit easier to see. Okay, so what I'm going to do is after the first cycle of motion is finished, I'm going to set the signal that this robot is ready. So I'm going to write sim set enter signal. It suggests over here, and the name of the signal will be robot 1 ready. And I'm going to put a 1 over here, but this is not what I'm going to be using. I'm going to be clearing this signal and setting it for communication. Okay. So this robot is ready. So after it finishes one cycle, it'll send the signal that it's ready. What we want to do on the other robot is it's wait for this signal. So we're in the same while over here, on the same, it has the same thread function. So in here, what I'm going to do is, as soon as I enter the loop, I'm going to wait for signal, and the signal name is robot 1 ready. Okay, so what will happen? What will happen is that this robot, at first they were moving at the same time, and now this robot will only move after this robot has finished its first cycle. So let's hit play so you guys can see it. This robot moves, and after it finishes its first cycle, this one starts to move. Okay, so let's make it, oh, if you wanna, I think it stopped it too soon. Okay, so this one moves, and after it finishes its first cycle, it sends a signal to this robot and this robot was waiting for the signal, and it starts to move too. Okay, so let's make it a little bit more interesting. Let's make the robots wait for each other. So what do we need to do? We need to do the same thing that we did for robot 2 in robot 1. So what do we want to do? We want to send a signal that robot 1 is ready to this robot, and this robot, what it should do is that wait for this signal, and as soon as it waits and finishes one cycle, it should send a robot that it is ready, and then this one should be waiting for the signal. Okay, so let's go step by step. So we're going to make the robots wait for each other so they don't execute anything at the same time. We're going to make them coordinate and communicate. So one robot at a time will be executing. So let's go to this robot first. Okay, so what will happen is that if both robots are waiting for each other, they're never going to start. So I'm going to break the tie with this robot first. So what I'm going to do is before this cycle starts, I'm actually going to set a signal saying that this robot is ready, just so one of the robots can start moving. Okay, so I'm going to start saying that this robot is ready, so this one can start moving. So in the code of this robot over here, I'm going to, before I start looping forever, just before the loop, I'm going to set the signal that this robot is ready to 1. Okay, so sim set signal, and this one will call robot 2 ready. Okay. I'm going to, okay. So the first thing that we need to do after this is, what are we going to do every time? We're going to wait for the other robot to be ready. Wait and wait for signal. So we're going to wait for robot 2 to be ready. And after this finally happens, after robot 2 sets the signal, what we need to do is immediately clear it. So if we don't clear the signal, what will happen is the signal will stay on and this will continue the loop forever. But we want to execute it only once. So only once per time. We want to wait for the robot 2 to be ready every time we're executing the cycle. So I'm going to clear, sim clear, and signal, I'm sorry. So it executes only once per signal. So robot 2 ready. Okay, so let me do a little rewind, just if you feel a little lost. So this, what we're doing right here, is just to break the tie. This is so one of the robot starts. In this case, we want robot 1 to start first. So we're telling it, okay, so robot 2 is already ready. So after that, what we want to do on each loop is wait for the robot 2 to be ready, and as soon as we get this signal, we clear it because we already received it and we don't want to loop forever. We want to wait for the robot 2 to be ready every time that we execute this code. Okay, so after we clear the signal, we execute our motions and then we say we are ready. Okay, so this part of the code is finished. Now, what we have to do is go to the second robot and make it send the signal to the first robot that is ready. So, in here, in this loop, what we're going to do every time is wait for the robot 1 to be ready, and as soon as we get this signal, we're going to want to clear it for the same reason than before. So, sim clear, enter her signal. And we clear the signal so we don't use it again. So in this loop, robot 1 ready. Okay, so what's robot 2 doing? It's waiting for the robot 1 ready signal. Once it gets it, it clears it so it doesn't execute this loop many times. And after it's finished with these movements, we want to tell the first robot that this one is ready. So we're going to set the signal. Set enter her signal. And in here we'll write robot 2 ready. Okay. And we're going to put a number 1. So this should be enough for one robot to wait for the other. And if we hit play, you'll see that this one moves first. It sends that robot 1 is ready, and then this one with the single clears it, and then says that robot 2 is ready, and this one was waiting for robot 1. So they're waiting for each other. The code, it's basically the same between, so both robots are waiting for the other robot to be finished. They wait for the signal to be ready of the other robot, then they clear the signal so they don't use it again for that loop. And then when they're finished with their movements, they say they're ready. So the only difference between both codes is that for this first robot, I'm actually breaking the tie. So before the loop starts, I'm actually saying that the robot 2 was ready. So one of the two starts. So this is the first part of the lab. The second part of this tutorial, what I wanted to show you is how to use the signals between sensors and robots. Okay, so now we know how to communicate between robots. And what I want you to do now is how to send a signal from a sensor to a robot. So many of you guys already did this in lab 2. And to make things a little bit faster, I'm going to actually copy this proximity sensor from lab 2. So I'm going to go to a proximity sensor. This is a proximity sensor. Do you remember it? This one, what it did is when I'm going to actually play it and remind you. Basically, what it did is when it sensed a piece, it made the conveyor belt stop moving. So this is all that it was. So when it got there, when it detected a piece, it made the conveyor belt stop moving. So I'm going to copy this sensor in here and paste it in our chocolate factory. And I'm going to get close and put it near our chocolates. Okay, so these chocolates are very, very, very don't have a great height. So I'm going to get really close to move it just using this. Okay, so I want to move it really, really, really low. Oh, it might be. Okay, so I'm going to move it again. Let's see. Okay, so I'm gonna want to move it almost on the conveyor belt. And I'm going to move this a little bit closer. So this is a proximity sensor. I already moved it because I'm going to move it a little bit closer. This should be enough. Okay, so we've set the sensor. What do we need to make this sensor work? So the first thing that I want to know is for this part, you want to put the code for reading this sensor in a non-threaded script. Why is this? Because we want to be reading this sensor on every simulation step. So if, by the way, if you don't have any non-threaded script, what you guys can do is you can just right click and hit add. You can grab actually any element in here. For example, a light. You can click it, do add, and then you select associated child script and just choose non-threaded, and here it is. Okay. I can put it on the parts producer, but I'm going to put it in. I'm going to put it in this non-threaded script right here. So I added a non-threaded script to default light A. And if you go to the non-threaded script, when you add a new non-threaded script, this code will always be here. We're only interested in 2 elements of this structure. So we're interested in the part that says initialization and in the part that says actuation. The other part we're not interested at all. So what's the code that we need to make this sensor work? It's very, very simple. Here it is. So we first need to get the object handle of the sensor so we can manipulate it. And after we initialize our sensor, what we're going to do is actually read it. So this function in here reads the proximity sensor, and in here what it receives is the object handle of the proximity sensor. Okay, so this sensor goes in here, and this R will tell us if the proximity sensor detected something or not. So if the R is greater than 0, this means that our sensor actually detected something. What do you want to do when we detect something? We want to set a signal that says pick up chocolate. And in here, when we send something, VREP actually gives you the object handle of the element that you detected. So I'm going to put this as the value of the signal that I'm that I got just in case we need it later. You guys need it later. Okay, so if we detect something, we set this into her signal pick up chocolate. And after we're not detecting anything, since this, if we don't detect anything, we want to clear this signal. Okay, so I'm going to copy this and go to our non-threaded script. You can do it in here, but you can also add it to any of the non-threaded scripts that are already there. So this code will be a little bit cleaner, so I'm going to, that's why I added a new one. So, okay, the thing between, the difference between initialization and actuation is that the code in here will only run once, at first, when the simulation starts. And this code will run on every simulation step. So, here's our code. BREP really tells you that you shouldn't put any code between the ifs. Okay, so you can put code inside here or inside here, but not where I just pasted it. Okay, so the declaration of our sensor, we only want to do that once. So I'm going to go to the initialization part and I'm going to paste this declaration of the sensor. And what I want to do with the rest is this, I actually want to read the sensor every simulation run, so I'm going to paste it in here. Okay, so in here we declared our sensor, and in here what we basically are doing, oh, this should have, okay, so it was a little typo. So in here what we are going to do is if we detect something, we're going to say the signal pick up chocolate. So I'm going to modify the code of this robot so it actually moves after it detects that chocolate. So if I go in here, I'm going to actually comment all of these. And instead, what I'm going to do is, since the script is in charge, since the non-threaded script is in charge of setting and clearing the variable, in here, for every time I go into the loop, what I have to do before I execute everything is I actually have to wait for the chocolate to arrive. So scene wait. For signal. And let me check the number of the name of the chocolate again. It should be pick up chocolate. Okay. The name of the signal. Okay, so this will be pick up chocolate. And if I hit play, what will happen is that this robot will only move when the chocolate passes through here. Okay, so you actually guys have to time put this sensor on the right place so it's timed with the movements of the robot. This one will actually not pick, this will not pick a chocolate because then I would be doing the lab for you. This is just going to move after a chocolate passes through here. So this robot will not move because I haven't changed this code, and this code is telling the robot to wait for this one. Okay, so as you saw, as soon as we detected the chocolate, it moved. Okay, so it's waiting, and as soon as we detect the chocolate, it moves. So now you know how to do sensor robot communication and robot communication. This will be all that you need to create the cooperation environment that you need for both of the laboratories.